Because this course is is a combined course as stats 1 and stats 2. Before this, if let's say we have stats 1, so the schedule is a bit loose lah, so I can have like maybe a revision session before your mid-sem exam, but this time around I cannot skip any session because otherwise we would not have time to cover the whole topics. Yeah. Okay, so if you have any question on LU1, LU2, please email me. Okay, please let me know. Sometimes I might not be really aware of Telegram, so if you email me, that could be better lah. Okay, all right. So let's resume with today's lecture. Today's lecture is on LU3. We continue from the previous topics. Okay, so previously we have kicked off the LU. We have talked about observed distribution, standard distribution, and then under standard distribution, we have discussed about discrete distribution, right? Binomial and Poisson. So that's what we covered before Raya. And today we are going to cover continuous distribution. Okay, remember the difference between discrete and continuous. Discrete is something to do with whole number. Yeah, so there is no decimal point. Something to do with like 3 persons or 3 cars, 5 schools. So it's like a whole number. That kind of number is called whole number. Continuous is something that is yeah, as the name implies, continuous. Like if you talk about weight, 56.1, 56.2, 3, 4, 5. So there is no limit for that. Okay, so that is meant by continuous. So today we're going to look at continuous distribution. Yeah. So both the discrete and continuous, they are under standard distribution. So standard distribution is something that is related to formula or table, something that has been standardized by statisticians. So you would refer to tables, formulas a lot. Yeah? So today we're going to cover normal distribution. Okay, I hope that this topic is just a revision for you, because I'm pretty sure that you have covered this in your high school, when you studied APPROXIMATIng, right? Normal distribution. So I still remember I studied this, and this is actually my favorite topic during my school time. So normal distribution. So when we talk about normal distribution, is something like a bell shape, something like this, symmetric. Yeah. So the characteristic is it's symmetric. It's what another name is we call bell shape curve, yeah? Because it looks like a bell. So another thing that you should know is this one is what we call tell, right? This is if you have something on the left and on the most right, this is what we call tell. Okay, this is peak, right? So the term, and then another thing that you should know is the area. This is what when we shade the area under the curve, this is under the curve. So this one is area under the curve is equal to the probability. Probability. Okay, so that's the thing that you should know about your distribution. Okay. So let me see. This one is a bit. I need to get another version because this one is. Hold on. This is better. Okay, so here is the outline of today's topic. We're going to have a look at basic properties of normal distribution. Normal distribution versus standard normal distribution. So there is another term here. So what's the difference between the two? And then probabilities and percentile determination and approximation of binomial distribution with the normal. So there are 4 subtopics under this chapter or this topic. Okay, so normal distribution. So I've talked about it just now. Is also equal to is also known as bell-shaped curve. Symmetric because it divides equally like this. So means the area here is equal to area here because it is symmetric. And the difference of one normal distribution to another normal distribution is in terms of the height of the peak. So this one is peak, right? So the height could be different. So it could be the spread like this. This is shorter, isn't it? So when the peak is shorter, the spread is wider. The spread is near the area below. Yeah, so they could be of different shapes. But one fact that is shared by all the normal distribution or normal curves is that the area, when I say area under the curve, is this one, whatever the area below the curve. Yeah. So this one, the total area, if you talk about the whole distribution, when I say the whole distribution is from the beginning to the end of the curve. Yeah. So the total area under the curve, regardless of whether it has high peak, short peak, is always equal to 1. Yeah? Okay, that is the fact that you have to know, isn't it? I think you have known about this before. So that one is a fact that you have to know. Yeah? It's not stated in the question. You are expected to know by yourself. So why 1, 1? Because this one, actually, total area is equal to total probability. Probability is the chance, right? So 1 is, if you convert it into percentage, is 100%. 100% convert to decimal, divide by 100 is equal to 1. Yeah? So that's why it's 1. So yeah, the chance is 100%, right? So that's why it's 1 when if you convert to decimal points. So meaning to say that if let's say in the calculation, let's say you calculate and you found that your answer is maybe 1.5, accidentally to be 1.5. So there must be something wrong with your answer. So you have to check. So that's why you have to know this fact, and you have to always remind yourself. Sometimes you forget also. This fact you have to keep in your mind very clearly, that the total area should be 1. Couldn't be more than 1. So if your answer is 1.5, 1.7, 1.8, then there must be something wrong with your calculation. So you have to check. You have to check your calculation and make sure that it is below 1. Tengoklah kalau let's say the area is, area is not covering the full range, so it should be less than 1. Yeah? So that is logic. That's something that you have to relate with the logic. Yeah. Okay. So the two parameters that you have to take note is the mean and the standard deviation. Okay. So even in any distribution, you always have to relate to the mean and standard deviation. Okay. Normal distribution is the most used statistical distribution. The reasons are normality arises naturally in many physical, biological, and social measurement situations, and that has made its normality as important in statistical inference. So when we say normality, I've mentioned about this. This is the trend that has been observed by the statistician in many cases. So when we talk about distribution of marks, distribution of weight, distribution of height, distribution of whatever the attitude behaviors. What the statistician found out is that the trend of the whole distribution always in the bell shape curve, or in a normal shape like this. Meaning to say that if let's say I do a survey of height, okay, height among UNIMAS students. Okay, that's my sample of study. So when I do the observation, so I would find out that not many students are too short, not many students are too tall. So that falls under this. Let's say the range is between maybe 145 cm to 100. Maybe this one about girls, 70, let's say. Okay, so that is the range that I have found out. And what I discovered from the distribution of my sample, I found out that not many are too short, maybe like 1 or 2 students in this area. Okay, and not many UNIMAS girls are too tall also, maybe like this 175. So maybe like a very small population have a height of 170. So that population, or that number of students fall into this site. Yeah? Whereas I found out that the majority of the girls at UNIMAS maybe have a height of 155 to 165 maybe. So it falls under this. So when I graph the distribution, yeah, when I when I graph the distribution, I found out that it looks like bell shape. So that is meant by this statement. So in many cases, in many observations, the distribution looks like it satisfies normality trap. Okay, so this is normality. So that's why normal distribution is a very important distribution in statistics, because it exists in most of the cases, and especially when the number of the samples, let's say number of my samples just now is 50, like is considered high, because in statistics it is more than 30, more than 25 is considered like it will more likely to reach to satisfy the normal shape curve, the distribution. So if the n is bigger, the bigger the n, the sample, the more chance the distribution will look like a normal distribution. Okay, that is a fact, that, or that is a trend, a normal trend in many cases. Okay. So yeah, so that's the reason why normal distribution is very important in statistics. Okay, so normal distribution is characterized by 2 parameters, the mean and also the standard deviation. The mean is the average. Standard deviation is, it actually describes how much the deviation between every point with the mean. Okay, yeah, so that's the standard deviation. Okay, this one you don't have to worry about this formula. It will not be used. But it's just to introduce you how the distribution or the parameters are derived. But I don't think so. Don't worry about this formula. Okay, so that is normal distribution in general. When we talk about standard normal distribution, so there is another term introduced, standard normal distribution. So it means that the normal distribution has been standardized. When we say something has been standardized, it must be something that has been how to say standardized, in other words, something that has been benchmarked to something. Okay, so when we talk about standard normal distribution, so what's the difference? It has been, sorry, I don't have any words rather than standardized. It has been standardized, it has been benchmarked to something, so that the symmetry of the distribution, it will be 0, like this. Okay, so yeah, so that's the difference. Whereas if we talk about just now, just normal distribution, we don't talk about the values of the fit over here, because it is not standardized yet. It's just a normal distribution. Okay, so when we talk about standard normal distribution, what you have to know is that now we are talking about the axis, the x-axis here. The values of the axis, the values of the x-axis is now, we call it z, whatever the values that we refer on the axis. Okay, and the symmetry lies at 0, or origin. Okay, so it means that the mean here has been standardized to 0, and the standard deviation is 1. So it means that the difference between this to this is 1. That's what is meant by the first statement of that. Okay, and now we refer the values on the x-axis as z. Okay, so z. So the total area under the curve must be 1. Okay, I've mentioned about it. Every point on the curve must have a height that is at least 0. So here you can see that another thing that you have to take note is the y-axis. The distribution lies on 0, starting from 0. So there is no negative heights. Okay, so we only consider the positive axis for the y. Okay. Right. So this formula is important. So this formula you have to remember. So if you do lots of calculation, you will remember this formula. So how are we going to transform normal distribution to standard normal distribution? We have to use this formula. So whatever the values in any normal distribution will refer as x. Okay, I'll show later how to use this formula. But you have to transform the x into z, so that we can use the standard normal distribution, or the table. Yeah? So you have known about the table before, right? So only once you transform this x into z, and only then you can use the z distribution table. Okay, so x refers to any score or values from original normal distribution. Mu, this is called mu. The way how to pronounce it is a Latin symbol. Yeah, so that symbol refers to the mean of the original normal distribution, and this is sigma. Okay, it's called sigma. This one is standard deviation. So if I call sigma mu, you should know what it means. Okay, so that's the formula. The z-score always reflect the number of standard deviation. Yeah. So let's say we have an example here. So the original questions is up to this. Okay. A person scored 70 on a test with a mean of 50 and a standard deviation of 10. Converting the test scores to z-scores, okay, and x of 70 would be, so you have to use the formula, this formula. Okay, so this one is x. Okay, mean of 50, this one is mu. Standard deviation, this one is standard deviation. Okay, so how you substitute into the formula, so you just substitute and you got the z value as 2. So meaning to say that if you plot, if you visualize on the standard normal distribution, so this z is 1. Okay, so this is the score. So it means that if we talk about the whole area, this is 70%, or the x is, the score is 70 and the z is 2. Okay. All right. So this is just a a very simple question. One important use of the standard normal distribution is for converting between scores from a normal distribution and percentile ranks. So what does it mean? So I think it will be, that will be understood if I solve this problem. Okay, before that now. Okay, before we go into that statement again, so some introduction of the Z table. So by right, you should know how to use the Z table. So you have used it before, right? Let's go into the table. So this is what is called normal distribution table. Okay, so if you see here, the Z value is given on the most left column, yeah, and what's the area, what's the value inside here means. This one is the area. Okay, so how to use this table? So if you see the graph on top of the table here, so you will see that the area tabulated is enclosed by the region where the Z lies. So it means that this is from 0, isn't it? So if let's say you're talking about, you're just talking about one side from here. So if let's say the Z is 0.92, let's say, yeah? Okay, let's say 0.92. So the area will be read from the 0 axis to Z equal to 0.92, which is this one. So this is the area enclosed by the Z equal to 0.92. So what's the area? So if you read from the table here, 0.92, isn't it? Okay, so that's the value of the area. So the value here is 0 point. You can see the point before 3, isn't it? So this area is 0.33212. Okay, so that's what it is meant by the Z and also the area enclosed by the Z value. So you can see that here, we remember the rule of the normal distribution, right? The whole area should be 1, isn't it? The total area should be 1. Total area. But here, the table only gives one side. So you should use your logics. So this one, it means that this area is 0.5, isn't it? So this area is 0.5. So you just, because of the symmetric characteristics, so if you know one side, you can just multiply. Like if let's say you need to find two sides. Yeah? So here, if let's say 0.3212, so it satisfies the condition that it should be less any area enclosed on whatever by the Z value, it should be 0.5 less or equal to 0.5. It couldn't be more than 0.5 because it's only one side, isn't it? So now it's 0.3212 is less than 0.5. So it's makes sense lah. It makes sense. Okay, so I hope you know how to use this. It's just a revision actually. You have thought about it in your high school. Okay. Right. Now let's have a look at an example. How to find the probability of Z less than 0.45. Oops. So what does it mean then? So find the probability. Find the probability of Z less than 0.45. So for this topic, I would suggest you guys to sketch a lot, to sketch where the region, the area that you are looking for. So that would help you to visualize what you want to look for. Okay, for example here, Z less than 0.45. Okay, if let's say we want to sketch that less. Okay, now the table just now, it just gives you one side. But whenever you want to solve the problem, you have to apply the whole distribution. Okay, so for example, in this question, if we want to talk about z less than 0.45, okay, so this one, let's say this one is 0. Okay, this one is z equal to 0.45 less than. So it means that the area should be anything that is less than z equal to 0.45. So that's what it means. Okay, so now we know that the area here is 0.5. So you don't have to look for it, yeah, because it covers the whole of the left area. So the only thing that you should look for, okay, now before that, what is meant by the probability here? So here, probability is equal to area under the curve. Okay, so that's why I emphasize on the regions. So whenever you say find the probability of z less than 0.45, actually you are asked to find the area under the curve, which is 0.5 for this one. Okay, and the remaining task for you is to find the area here, isn't it? This area. Okay, so you know that the z is 0.45. This one is quite straightforward. So if you refer to the table, you just go for 0.45. So 0.45. So the area that on the right region is 0.1736. This one is 0.1736, the area. Now you want to find the whole area, isn't it? So means if you want to write it properly, the P Z less than 0.45, you have to consider the region on the left, which is 0.5 plus 0.1736. So the total area is 0.6736. Okay, so that's how you look for the answer. So probability, it should be less than 1. So it should be less than 1 because this one doesn't cover all. So this one makes sense. It's less than 1. So that's how you check. Yeah? Okay. Second example. So this one is quite straightforward because you don't have to use any trick. You just go directly to the table, get the values, and you don't have to subtract anything. Okay, so in some questions, they would play some tricks with you. Okay, for example here, find the probability of z more than 1. Okay, so that's why you have to understand the question very carefully. So this one, if you want to sketch, it belongs to this region, isn't it? Okay, if you want to have z equal to 1, so more than 1, so it should be this area. So this is the area that you are looking for. So now, if you want to look for the values in the table, okay, so because of the table says that, if you see here, so the area is given from 0 to whatever the z value is. So in order to find this area, let's say we name it as area B, you cannot go straight forward, isn't it? You have to find first the whole area. I mean, you have known it as 0.5. So you have to subtract area A from 0.5, isn't it? So this is logic lah. This one, once you understand the principles of normal distribution, everything else is common sense. This one common sense lah. 0.5 minus area A is equal to area B, isn't it? So tak susah lah sebenarnya. So how to find area A? So you go to the normal table, right? Find z equal to 1. Yeah? So z equal to 1, the value here, this is the value, 3413. Okay, so that's the area of A, 0.3413. So 0.5 minus 3413 is equal to area B, which is, okay, this one is, yang ni cara, what I shown here is the easiest one lah. If you calculate this, how much is this? It's, I think it's equal to 0.1587. So the examples given here is, it considers it, this one is a bit tricky lah. I would suggest you to refer to this, to my workout, which is actually more straightforward. You don't have to worry about the regions, this site at all. Okay, that's why you have to you need common sense lah ni. Okay, sometimes some of the workout dalam slides ni it's not from me, so they might be different. Tapi at the end you can see the answer is the same. Sorry, the answer is the same. Okay. So yang ni dia consider the whole area plus this one, tapi minus pula yang tu. So actually dia sama je. This one is actually much easier. Okay. So the question can be different lah. Can be you know, they can play tricks with you how to find the area of this and the area of that. And this one, so this one you have to apply the symmetric, right? So you know that it is symmetric. So whenever it is -1, although -1 is not available in the table, in the Z table. So if you equalize it to Z equal to 1, so this area should be equal to this, isn't it? It should be the same because of the symmetric characteristics. So that's why you have to understand, you have to remember the symmetric characteristics. You have to remember the total area should be 1 divided by 2. Each of the region, left axis, right axis should have 0.5. So from there you can play around with whatever they are, whatever the question asks. Okay, like this one, you apply the symmetry. So although -1 is not available in the table, you apply this Z equal to 1, you can find this area, subtract this one first from 0.5, you will get this area, and this area would be equal to the area on the left because of the symmetric characteristic. Okay, this one is another trick. How you want to find in the middle. So that's me straightforward. So you divide by 2, isn't it? So this one is you can find straight away from the table. What's the area of, let's say you label it lah, you label A. This one is B. So A is equal to B. So at the end you just, okay, this one is a bit, that's why I said you don't have to rely entirely on the workout. Sometimes the workout is it takes a long workout. Tapi if let's say you apply the same rule, the same concept, you would actually find the area. So if let's say here I apply my method 0.3413, yeah, here. So this one, A is equal to 0.3413. You know that A is equal to B because of symmetric. So, but this one is 1 minus 1. This is 1, right? So it should be the same. So total area is equal to 0.3413 times 2, which is 0.6826. Yeah? So it's the same. Workout ni lain lah. If you don't want to understand this one, it's a bit tricky, you just go for my methods. This one is straightforward. This one can be applied if the Z value is equal. For example, 1 and -1. But if let's say you have something like this, let's say this one is 1, okay, the Z on the right is 1, and here is maybe 0.5, okay, and find the area and close by Z minus 0.5 and 1. So for this one, you have to apply, you have to find individually that A is not equal to B, right? So you have to apply what is A first, what is B. B, so you have to visualize for the B minus 0.5 is actually equal to 0 when Z equal to 0.5, this region. So that is how you refer to the table, find the area here, right? So B1 is actually equal to this. So faham tak maksud I? Okay, so when you find the area accordingly, then you just add up. So for this one, you cannot apply symmetric lah because the value here is not the same. Okay. All right. Percentile. We wish to find the 93.7 percentile of the standard normal distribution. So what is meant by that? Okay. So this one actually, the question, this kind of question, it asks you, what is actually the Z value? What's the Z value? Okay. So you know that percentile is related to percentage, isn't it? 93.7%. If you convert it into decimal points, it's 0.937. Okay, so how to solve this kind of problems? So first, you have to know this fact, you have to convert to the decimal points. So you have to sketch the graph, the distribution. Okay, so it means that this is 0.5, so it should be more than this axis, isn't it? This one is 0.5, so it should fall somewhere here. It shouldn't be towards the end. So it should be somewhere here. So this one is 0.5. This one is 0.937 minus 0.5 is equal to 0.437. Okay, so it means that the total area here is 0.5. The total area, this is total area, not the Z value. Total area is 0.437 on the right axis. So your task is actually you have to find what is the Z value that corresponds to that particular area. So how to find that? Okay, so just now we find the Z, find the area, but now we have to find the Z value based on the area that we have. Okay, so what's the value just now? 437. Okay, so you have to look for the Z value. So means you have to go for the values inside to the outside. Okay, so 437, find the nearest value. Okay, here. This one, right? Is it 437? 437. So the Z value that you are looking for is 1.53. Okay, so that's how you get 1.53. So the Z is equal to 1.53. So this is meant by this question. You are asked to find the Z value. And sometimes you are asked also what's the X value, but but in this question it's not stated the mean and the standard deviation, so you just end up until Z value. Okay. All right. For example, this one. So we wish to find what's the Z enclosed by 0.96. The same thing like this now. So you draw the graph. 0.96 should be somewhere up to here maybe. So this one is 0.5. So this one is 0.46. Yeah. So what's the Z value that enclosed up to 0.46? Okay, this one. So refer to the table 0.46. The nearest one is this one, 1.75. Okay. So sometimes you might not get the actual value, so just go for the nearest ones. So it's 1.75. So the Z is 1.75. So that's how you solve for it. Okay, the rest here is the same, it's just some tricks. Maybe this one, you apply this one. Okay. We wish to find Z 0.04. So this refers to the tail area. The tail area. So how to find it? So you apply symmetric kat sini. So maybe This one is 0.0401. So if let's say you don't want to solve, okay, another way is you divide it uh, into the regions. Okay, so this one you know the area, which is symmetric with this. So this one, the whole area is 0.5, isn't it? So this area A is equal to 0.5 minus 0.0401, which is equal to 0.35, 0.5 minus 0.0401. So this area is 0.4599. Okay, the reason why we have to find A, the area A here, because we want to find the Z value, isn't it? So if you refer back to the table, 4599 is this one, 1.75, isn't it? So the Z here is 1.75. But remember, this one is on the right axis. It's given just now 0.041. So the Z should lies on the left axis. So instead of putting it 1.75, you should say Z is equal to 1.75. Okay. Right. Given that the distribution, okay, there are so many questions like actually this one is you just apply your understanding about the formula and also the region. Okay, let's have a look at this question. Given that the distribution of adolescent IQ scores is normal in shape with a mean of 100, okay, so now it's given a little more extra information, mean of 100, standard deviation of 15 points. What is the percentile rank of a child whose IQ is 120? Okay, so the question is up to here. Okay, this is the solution already. Okay, this is the question. So when you are given this kind of question, so this is normal in shape. That's an important point because from here it lets you to use the normal distribution. So this one mean, this one is mu, isn't it? This one is sigma or standard deviation. And this one is actually x. It's not z, not z yet. Huh? So means that in order to use the normal distribution, you have to use this formula. Okay, this formula, you have to convert the x into z first. So when you substitute the value x 120, mu 100, standard deviation 15, you got z equal to 1.3. Okay, 1.3. So where is 1.3? So you should sketch by yourself. Okay, z equal to 1.13. So it should be here. Okay, so considering the whole distribution from the beginning, so this is actually the area enclosed by it. So means you have to find what is the percentile rank. First, you have to find the area. So after that, after you got the area, then you convert it into percentage. Okay, so the area here, so you just consider this one is already known, 0.5. So you just have to find the area over here, isn't it? So this one is 1.3. So this is quite straightforward. Z equal to 1.3 is this one, this value. 0.4032. So means this one is 0.4032. So when we talk about total area enclosed by or total area or probability is the same. PZ less or equal to 1.3 is equal to 0.5 plus 0.4032, 0.9032. So this one is not yet the answer because this one is in the decimal point, isn't it? Percentile rank. Percentile means it should be in a percentage. So you convert it to percentage, multiply by 100, 1, 2. So the answer should be 90.32%. Should have a percent at the end. Okay, so that's the answer. Or if you run out, you can say it's 91st percentile. But if you answer 90.32 also can. Okay. So the same thing, this is just a little variation of the question below 90. So maknanya you convert first, and this is x. Okay, the same thing. This is mu. This is no, this is mu. This is sigma. Find the x. Find the z. Sorry. So the z is minus 0.67. So you know that the region lies on the left axis. Because z is equal to minus 0.67. Minus 0.67. So the area is actually here. But in order for you to find the area, you have to apply the symmetry. Okay. So this one is actually equal to this area when z equal to 0.67. Okay. So how to find this area? You have to find this area first, right? Let's say this, the area, the tile area that you're looking for is B. So you have to find A first. So how to find A? You know the total area here is 0.5. So A is, the total area of A is, if you refer to the Z table, 0.67, this one, 2486, right? 2486. So A is equal to 0.2486. So D is equal to 0.5 minus A, which is 2486, is equal to 2514, 0.2514. So 2514. So you apply that 0 because that tile area is symmetric to the knee. So actually this one also 0.2514, the area. Percentile, convert to percentage, 25.14%. Okay, so that's how you got the answer. Okay, so the rest I leave it to you to have a look at yourself. Okay, the question is just a trick on which side. So you just have to apply the concepts that you have understood. Okay. What else important here? Okay. So there are some questions for you to do to practice. Okay, ini pun sama lah. Dia convert X to Z and then find the area. Okay, that's why the sketching on your sketching is important, because without sketching you may not be able to see what region that you have to solve. Okay, so I go to the last one. Approximating the binomial with the normal. So before this, we talked about binomial distribution, kan? So binomial distribution, it is said as not convenient in some circumstances. So in some circumstances, we can actually use normal to approximate the binomial. So how it is possible? Okay, so some facts about normal. Normal distribution is actually much easier to use because of its simple single table. Whereas if we talk about binomial distribution table, remember, it depends on the n value. N value, it could be different from one case to another. So if let's say we have n equal to 100, so the table would be actually is very complex, very difficult to get information from such a long table. So that's why binomial distribution is not that really convenient. So in that case, we can actually use normal distribution to approximate the binomial. Okay, so in what cases? So these two conditions must be satisfied. So first you have to check what is the value of n multiplied with p. Is it greater than 5? And also the values of n multiplied by q. Remember, p is the event, the probability of one of the events. Yeah? So it's given in the question. So let's say 0.2. N is the number of sample. So you have to check the values of n multiplied by p, and also q, this one is actually 1 minus p. So once you know p, you know what's q, because you just subtract p from 1. Okay, so these two conditions must be satisfied. before you approximate binomial using normal distribution. It must be greater, both of it must be greater than 5. So when you have checked that, let's say both are more than 5, and only then you can proceed with the normal distribution. So you have to proceed by finding the mean by using this formula, and also this standard deviation using this formula, square root of n per q. Let's have a look at one example. Or before that, continuity correction. So for this one, only for approximation of binomial with normal, for the range, let's say the range is controlling x between 3 and 4. So you have to do what we call correction. Correction means that you cannot go straight forward to 3 and 4. So you have to do, you have to subtract 0.5 from the left, so that it is going to be 2.5 instead of 3. And for the 4, you have to add 0.5. So that is what is referred to as continuity correction. Okay. So you are actually looking for this range actually. Okay, let's have a look at an example to make it clear for you. Okay, from years of observation, biologists know that the probability for any given Arctic tern to survive the migration to its winter feeding ground is only 0.65. I see. This one is actually P. Probability to survive. Okay, so this is actually P. So P is equal to 0.65. A random survey banded 500 Arctic tern. So this one is N. N is equal to 500. Okay, if you see N is 500. So if you use binomial table, it's going to be very difficult to find N up to 500. If you remember the binomial table. So based on that, we can actually try to use normal distribution to approximate this binomial distribution. So what are the first thing that we have to do? We have to check N times P. What's the value? Okay, so N is 500 times P is 0.65. So that's give 325. Okay, so this one obviously more than 5. So means it satisfies one of the conditions just now, right? So the next thing is we have to find N times Q. So how to find Q? Q is 1 minus P. So 1 minus 0.65. This one is a formula that included in binomial, if you still remember. So this one is 0.35. Q is equal to 0.35. So N is equal to 500 multiplied by 0.35. That's equivalent to 175. So this one is also more than 5. So means both conditions are met. So we can use normal distribution to solve this problem. Okay, so now we have to find what is the mean, because mean is not given, isn't it? So we can use this formula, this one and this one. So mu, the mean is equal to NP square root. Standard deviation is equal to square root of NPQ. That is the standard deviation. Okay, let's solve for that. Yeah, so this is mu, right? Mu. Okay, this is the mu value. And the standard deviation is square root of NPQ. This is the standard deviation. So why we need these two values? Because we want to transform the x into z value. Remember? Okay, now the question asks, okay, the question is here actually. So find the probability between 310 and 340 will survive the migration. Find the probability of this one. Okay, this one is actually x. X. So means that we are looking for the probability of x 310, 340. But remember, for approximating the binomial, we have to apply correction. So this is what is meant by minus 0.5 plus 0.5. So you are not actually looking for this one, but instead you have to consider the subtraction of 0.5 from the left tail and addition of 0.5 on the right tail. So you are actually looking for 310 minus 0.5 is 309.5, isn't it? And x 340.5. So this is what is meant by the correction. Yeah? So this is the new value of the range actually. And this is only for when you approximate the binomial with normal. For normal cases like before, when we solve the examples or the questions under normal distribution without this binomial thing, you don't have to do the correction. So you just use the values straight away. Okay, but for this you have to apply the correction. So you are actually looking for this probability. And remember, this is still x. So you have to convert to z. Okay. So remember the z is equal to x minus mu divided by standard deviation. So this is the formula applied for both sides. Okay. So we know that the mu is 3 to 5 as of here. Yeah. And sigma, the standard deviation is 10.67. So that's how you solve, you substitute into this. Okay, so it's actually from this formula z. So once you convert the x into z, you get this value minus 1.45 and 1.45. Only then you can use the standard z table. So sketch the region. So this one is easy because it's symmetric. 1.45 minus 1.45. So this is actually the region or the area that you are looking for, area. So since this one is the same value, 1.45 on both sides, so you just apply the symmetric characteristics, find the area of on the right side when z equal to 1.45. Okay, look for the z table, 45 and the semi end, 4265. Okay, so this one is actually 0.4265. But remember, you are considering both sides, you have to multiply by 2. So 4265 times 2 is 0.853. Okay, so if you don't understand this workout, this one, not to say it's not correct, it's a bit lengthier lah. You just go straight forward to my methods. My method is senang lah. Multiply by 2, 853, which is actually equal then. So some of the workout in the slides a bit tricky, so you just refer to my methods. Okay, so that's how you apply it. That's how you solve for it. So the answer is this one, 0.853. So that answers the question. Find the probability that between 310 and 340. So you can see that you can check 0.853 is less than 1. So that makes sense, yeah? Because it should be less than that. Okay, so that's about it for this topic. Okay, first you have to know the normal distribution, and then you have to know the standard normal distribution. You have to remember the rules of standard normal distribution, total area under the curve, the symmetric rule, how to use the z table, and the last part is the approximating the binomial with the normal. Okay, so you have to check the condition first, NP and NQ, whether they are more than 5. If both are met, then you can apply the formula of mu, mean, and also the standard deviation to find the two values. And then apply the continuity correction, minus 0.5, 0.5 on the left side, plus 0.5 on the right side. So, and then, so you solve for the area, so when you solve for the area, it's actually the same like before. So you know what region you are looking for. Find the probability. Probability means area under the curve. Okay, so you refer to the z table. Okay, that's it that's all about. That's what this course, this topic is all about. Um, yeah, so it's actually quite easy. It's normal distribution. I focus on that topic now. Okay. Right, so yeah. Kalau tak ada apa-apa, then we can disperse now. Okay, so don't forget this Saturday, we're gonna have our mid-semester exam on ELIP exam. It's not on ELIP, on the normal ELIP. Okay, any question? Siapa yang raise ni? This one will be included in the final exam lah, LU3 ni. Okay. Okay, if you have scanned your attendance, you may leave. Yeah. Have a nice evening.
Thank you, Doctor.
All right. I'll inform from time to time about the exam on Telegram and also on e-link. All right, welcome.